Okay, writing formulas for ionic compounds. Review the elements that form ions with a predictable charge. That's an instruction to me. Okay, let's review that. So, nonmetals form predictable charges. Periodic table, like for chlorine, you find it on the periodic table, you count backwards from the noble gases. The noble gases are 0, chlorine's -1. All the nonmetals form negative ions, and we can predict their charges from the periodic table. The metals are a little bit less predictable, but we've got groups 1, 2, and 3. So predictable charges are groups, for the metals, are groups 1, 2, and 3. They always form a +3 charge.
3 meaning bromine.
Boron, yes. So I really should put A's in here. 1A, 2A, and 3A. And the other ones are not predictable.
You said they always form a 3+.
Yeah, group 1A forms a +1. Group 2A forms a +2. Group 3A forms a +3. I believe we talked about the idea of valence electrons and the electrons being like skins on an onion. And so like potassium in group 1A has a little bit of a skin on the outside and it wants to get to a full skin. And so the easiest thing is just to take off that little piece, and then it becomes like argon on the outside by losing 1 electron. And so it becomes a +1. And so there's a pattern there because of the number of electrons.
Noble gases are automatically negative. It's to the left that's negative 1.
The noble gases are like the nobles of Europe, and they don't interact with the rest of us, right? So they don't form any ions. They are just completely self-satisfied. So they don't interact with anybody. So they are 0. They don't form a charge. But everybody wants to be like them, even though they're really stuck up and won't talk to us.
-1, -2.
Yeah, so these are 0. And you go to the left, and actually the periodic table really should be a circular, kind of a spiral thing. So if you took the periodic table and you bent it around on itself, here's 18, and the next one over here would be 19. And so potassium's charge, you still start at the noble gas and you go +1 to the right. So important idea is that ionic compounds always have positive and negative ions, because positives and negatives, opposite charges, attract each other. If you have negative and negative, they're going to repel each other. It's not going to stick together. It won't be a compound. And when we write a chemical formula, the sum of the positive charges has to equal the sum of the negative charges, because overall a compound is neutral in charge. Nature abhors a vacuum, and nature also doesn't like its charges being separated. So when we write formulas for ionic compounds, we're going to write the symbol for both ions first, including the charges. And students tend to want to skip this part, and you can skip it later when you get good at it, but you can't skip it now. We need to see the charges. The charges tell us how to put them together. So then look at the magnitude of the charge on each ion. You're going to have one that's a plus and one that's a minus. If those are the same, well, these are the book instructions. I'll go through this exact as it is without my own little thing. Make the magnitude of the charge on each ion without the sign become the subscript for the other ion. This is a method called crisscross, which works most of the time. It will occasionally get you into trouble, but it works most of the time. Then, if possible, reduce the subscripts to give a ratio with the smallest whole number. So that's what your book says. What I would say is for number 2, look at those charges. If they're the same, like if they're +2 and -2, just push them together. You need one of each. That avoids step 3. When you're done, check to make sure that the sum of the charges cancel on the cations, cancels the sum of the charges on the anions. And all of that is like reading the instructions for Monopoly, and doesn't make sense until you start playing the game. So let's play the game. So write a formula for the compound that forms from aluminum and oxygen. So the first step is here. Write the formulas with their charges for the ions. Aluminum. Well, how do we know that aluminum's +3 charge? We find it on the periodic table. It's in group 3A. Bingo, 3 plus charge. Oxygen, we find it on the periodic table. If you don't have a paper copy of the periodic table, you're going to want one because you're going to be looking at it a lot. So get one that you like. So here's oxygen. We count over from neon. -1 to fluorine, -2 to oxygen. That's how we know what the charge on oxygen is. You have to write the formula with the charge for both of the ions. Then you look at those charges. This is +3 and -2. 2 and 3 are not the same. They're close to each other, but they're not the same. So if we just put them together, one aluminum and one oxygen, overall they would still have a charge. And that's not how it works. So this is demonstrating the crisscross method. Those numbers are not the same. So we can take this number 3 and have it be the subscript on the oxygen. And this number 2 be the subscript on the aluminum. And this is the crisscross thing right here. Okay, and most students like that. Crisscross. There are other ways to think of this. The more math way is to look at that and see, okay, 3 and 2, what's the least common multiple of 3 and 2? It's 6. So I would need 2 of the 3 and 3 of the 2, and then it'll add up to 0. Okay, and if that's going to work for you, that's enough explanation. So I'm not going to go over that anymore. Then we can also do more of a visual method. So there's the one, and here's the other ion. And then let's keep track down here of our total positive and negative charges. So right now, with one of each of them, we've got +3 and -2. And that's not going to add up to 0, so we have a problem. We've got too much positive charge. So that means we need to add more negative charge. So the only way we can do that is by putting in another oxide ion. Now our total of negatives is -4. We're like, great. Now we've got too much negative. We have to add on the positive side. And so that makes +6. It's like fabulous. Now we're still out of whack. So we'll add another one over here. And we say, phew, finally evened out. Okay, so that's a more visual method. We need the correct number of each so that their charges together add up to 0. This reminds me of my Grandma Johnson. My Grandma Johnson enjoyed food. And when she would come over for dinner, we'd have bread and strawberry freezer jam. Or, sometimes it was just butter or honey, different things. She called it all with it. There was bread and with it, because you had the with it with the bread, right? So bread and with it. So she would take a roll, and she would take some with it, and she'd butter the bread and then eat it, and then there's with it left over. Well, you can't let that go to waste. So she'd ask for the bread to be passed around. She'd take another roll, but now there's not quite enough to put on the roll, so then she'd need more with it. And she could go on like that all day long until the bread and with it ended up being even at the end. And so that's what you're trying to do here, is you're trying to get the bread and the with it to even out, so that you get the same number of negative charges as you have positive charges.
So we're trying to get with it.
You're trying to get with it. Yes, excellent. Trying to get with it. So, any questions about this idea? Here's another example. And this is the book's example. So here's magnesium. We know it's 2+ from its position on the periodic table. Here's oxygen. We know it's 2- from its position on the periodic table. Your book blindly just crisscrosses and ends up with Mg2O2. And so then they say, well, you've got to look at this and see if it needs to be reduced. I think it's simpler to look at it first. We've got +2 and -2. 2 and 2, those are the same numbers. If we just push these two guys together, they're going to add up to 0. Done. Okay? So the crisscross thing works most of the time, but you do have to watch out for getting a a fraction, if we wrote that as a fraction, it would be 2 over 2. And, depending where in your math class you are, they're not going to like that. They're going to say, no, you need to reduce that, that's 1 over 1. So we want all of our ratios in these formulas to be the lowest ratio possible, so that we always end up with the same formula. Because yes, Mg2O2 is the correct ratio, but then why not write Mg63O63? That's also right. So we want to just have one correct formula, so we're going to go with the lowest. Do you have a question?
Yeah, I know magnesium comes first and then oxygen, right?
Mm-hmm.
Is it because it's on the left side? Is that what you mentioned? That's what you're...
Yeah, it's because that's how we decided to do it. So the more metallic element comes first.
How do you know if it's more metallic?
How do you know if it's more metallic? Well, in these ionic compounds, you actually have a metal and a nonmetal. So we've got our stair-step line, and the magnesium's over here, and it's a metal, and the oxygen is over here. It's a nonmetal. And so the oxygen is always going to go last. In chemistry land, the oxygen being a nonmetal is feminine, and so it's always Mr. and Mrs. Why? Just because. If you have two elements like sulfur and chlorine that are both nonmetals, then you would put the one that's closest to the metals first. So sulfur is closer to the metals than chlorine is. And that'll work most of the time.
What about like hydrogen?
Hydrogen, yeah, hydrogen's that squirrely little baby brother. Yeah, we'll talk about hydrogen when we talk about acids. So hydrogen sometimes goes first and sometimes goes last. Just because he can.
Switch hitter.
Yeah, he's flexible. Any other questions? So, do some examples. Write a formula for the compound that forms from calcium and bromine. So first step is formulas for the ions. The symbol for calcium is Ca, and it has the charge 2+, because it is in group 2A in the periodic table. Bromine has the symbol Br, and we look on the periodic table, and it's in group 7A. And so we start with the noble gases, krypton in group 8A, and we count backwards, -1. Bromine has a charge of -1. So we just write the minus. We don't write the 1 because chemists hate 1s. So we look at those charges, and we say, +2, -1, those are not the same. So we can do the crisscross thing. So this 2 becomes the subscript for the bromine, and this understood 1 becomes the understood 1 for the calcium. So we've got calcium and bromine with a 2. CaBr2. Any questions? Now's the time to ask if it's not just like super crystal clear. The basic concept of balancing charges is not complicated, but it's just weird, because if you haven't seen this before, it's just really weird. No questions? Okay.